Hi, for those of you who would like a bit more of an explanation on the homework assignment, here we go. All right, so we've already decided that when we have a compound between calcium and chlorine, those atoms will be held together with an ionic bond because we have a metal and a nonmetal. In an ionic bond, the metal loses its electrons, the nonmetal gains it, and that's what my visual needs to show. Calcium's in group 2, it has 2 dots around it. Chlorine is in group 17, it has 7 dots around it. The calcium will lose one of its electrons to the open spot or the lone electron on the chlorine. The chlorine atom is now stable with a full shell, but the calcium atom is not. So I'm going to need to add another puzzle piece that will gain electrons from the calcium. In this compound, that would be another chlorine. And then I show the resulting ions. Calcium has lost its electrons. It lost 2 of them, so its charge is 2+, no dots around it, show it in brackets. The chlorine has gained an electron and now has 8 dots around it, so its charge is -1. Put brackets around it because it's an ion, and I needed 2 of those chlorine puzzle pieces in order to satisfy the calcium. Moving on to number 2. The compound made between carbon and oxygen, so that its formula is CO2, 2 nonmetals, it'll be covalent. The electrons will be shared. The carbon piece has 4 electrons, and each of the oxygen puzzle pieces have 6. We had said in our notes, we always start with the puzzle piece that has the most number of bonding sites. That would be the carbon, and I'm going to click wherever carbon has an open bonding site, the oxygen puzzle pieces to it. Oh, that did not go over so well. All right, so if I zoom into this now, the oxygen atom on the left has access to 2, 4, 5 of its own, plus 2 shared, that has access to 7. The carbon atom in the middle has access to 2 of its own, plus 4 shared, so that's a total of 6. And the oxygen atom on the right has access to 7 electrons. No one is satisfied or stable with a full shell yet. So we have to talk more about how we can share. Remember that atoms can share either 2, 4, or 6 electrons. So if I take these lone electrons that the carbon and oxygen atoms have respectively and start to share them as well, in this fashion, it winds up that these double bonded carbon oxygens have everyone accessing 8 electrons and therefore a full valence shell. Because it's a polar bond and oxygen is more electronegative, I'm going to show that using those arrows with the little hash mark. The arrows point to the atom that's hogging the electrons, and the hash mark goes at the atom that's not hogging. There we have our carbon dioxide molecule. Moving on to problem number 3. Problem number 3 has barium, hydrogen, and oxygen in the formula Ba open parentheses OH close parentheses 2. I have a metal with 2 nonmetals, so I will have both ionic and covalent bonds. I like to start with the covalent bonds. The oxygen and hydrogen, those 2 nonmetals, they're going to be held together with a covalent bond. Perhaps some of you can already visualize that the hydrogen is going to click in to where the oxygen has a lone pair. Hydrogen's satisfied with a full shell. Remember, hydrogen's satisfied with 2 valence electrons. The oxygen, however, is not. It's still not a full shell. It only has access to 7 electrons. Well, in comes barium. Let's now build our metal here. Oops, excuse me. Barium is an alkaline earth metal. It has 2 valence electrons. If this grouping of the hydrogen and oxygen, if that molecule now steals one of barium's electrons, now that oxygen atom is satisfied with access to 8 valence electrons, or a full shell. However, barium still has this 1 valence electron that it wants to lose. So I'm now going to need a second set of this oxygen atom bonded to the hydrogen so that it can now take that second electron. Showing the resulting ions, barium no longer has any dots around it. It has lost 2 electrons, so its charge is 2+, and we put it in brackets. The next ion is going to be that oxygen, hydrogen. Together, the 2 of them gained an electron, so that means together there's a -1 charge. I put it in the brackets, and I have a 2 outside of it as a coefficient to show that I needed 2 of them. Within the oxygen, hydrogen, the oxygen is hogging those electrons. So again, I'm going to show the polarity of that bond. Moving to question number 4. Question number 4 has all nonmetals. So your first inclination is that you want to think that it's held together with covalent bonds. However, this NH4 is a polyatomic ion. And anytime you have an ion, you must have ionic bonds. And since they are nonmetals, you must also have a covalent bond within that. So looking at those pieces, we have a nitrogen piece, group 15, so it'll have 5 electrons, and we have 4 hydrogens. And then, of course, there's this chlorine puzzle piece. Once you identify your polyatomic ion, you know that those are going to be the atoms that go together. So nitrogen is going to be my starting piece, and I'm going to click in the hydrogens wherever there's, and now I'm going to have to rearrange the location of my atoms, or excuse me, my electrons, right? So I'm going to click this in over here, but to rewrite it more cleanly, so we have this. But there's this 4th hydrogen that it looks like it can't go anywhere. It looks like nitrogen no longer has any more bonding sites. However, if the hydrogen loses and gives its electron to the chlorine, that hydrogen now has no more dots. And as a result, it's going to sit where nitrogen's 2 dots are, and it's going to accept them from there. So when I draw that resulting ion, that's my NH4. It lost an electron, so it has a positive charge. Close it out in the brackets. And then my chlorine is full with the 8 dots. It gained 1 electron, so there's that -1 charge. And this area here, where the hydrogen clicked in after it lost its electron, that type of covalent bond is called a coordinate covalent bond. In other words, those 2 shared electrons came from the 1 atom. Now you may be asking yourself, how come we didn't lose, how come nitrogen didn't give its electron to the chlorine? And that's because nitrogen has a much higher ionization energy compared to hydrogen. And remember, nature likes things that are low in energy. It's much easier to take the 1 electron away from a hydrogen atom than it is to take 1 electron away from a nitrogen atom. So the hydrogen atom is going to lose its electron and therefore form that coordinate covalent bond where the 2 lone electrons from that nitrogen atom are going to wind up being shared. And finally, question number 5. Question number 5 has 2 nonmetals for a covalent bond. All of them are in group 16. So they all have 6 valence electrons. We have 1 sulfur atom and 3 oxygen atoms. So now we're stuck because all of the puzzle pieces have the same number of bonding sites. So we actually start with the one that's different. Sulfur is different, it'll go in the center, and the oxygens are going to start to click in just as we would have put them before. And now we have this one more oxygen atom where perhaps we can think about how we were able to shift and rotate and could form coordinate covalent bonds. If I were to rewrite this puzzle piece as this, or make it a little, I could now take it and attach it to where sulfur has some paired electrons. And now that oxygen atom has a full shell. The sulfur atom now has a full shell. However, when you look at the oxygen atoms on the left and the right, they don't have full shells. So you might now start to think, all right, I'm going to form some double bonds. If I take the lone electron out here and take one of sulfur's and put them in the shared position, you might look at sulfur and realize, now it's got too many electrons. It has 9 electrons, and that can't happen. However, the oxygen on the right still has access to 7 electrons. So if I take this electron that's on sulfur and shift it over to the oxygen, I wind up with a situation that looks like this. Now, because sulfur is surrounded by 3 identical oxygen atoms, there's no way to know that that double bond exists between sulfur and the oxygen on the right, whereas it could exist between the oxygen that we put at the top, or maybe it exists between the oxygen on the right. In real life, this double bond does in fact fluctuate, and it rotates, and it moves, and it does go between, it does go between all of the positions. And that is called resonance. Resonance. So in real life, each of these bonds is really like 1 1/3, because there's no real way to know which oxygen atom the double bond is existing between, because it's sulfur with 3 identical oxygen atoms. Some things to point out: when you're looking at these original puzzle pieces, or another way to think of the Lewis diagrams, here we had 4 puzzle pieces, each of them with 6 valence electrons. So there are a total of 24 electrons that I need to organize, no more, no less. And when you look at our final setup, we do have 24 electrons, no more, no less. And that's how we know that our structure is valid. If you have additional questions, please feel free to ask. I'm happy to go over them in more detail with you. I hope this was somewhat helpful to you and cleared up any confusion that you may have.